parallel plate capacitor. Objective: to find the capacitance of a parallel plate capacitor. In a parallel plate capacitor, two large conducting rectangular plates are kept side by side at a small distance. The gap between the plates is usually vacuum. Sometimes it may get filled with dielectric materials. Suppose a voltage source or a battery is connected across them through a resistor. We will look at the functioning of the battery and resistor in detail in the upcoming chapter of current electricity. For the time being, it is sufficient to learn that a battery maintains a constant potential difference across its terminals. The conducting wire attached to the positive terminal is at a higher potential, and that connected to the negative terminal is at a lower potential. This constant potential difference induced in the circuit due to the battery drives free charge that is present in the circuit. Coming back to the capacitor connected in a circuit. There is a gap between the capacitor plates that does not allow charge to pass through it. So, the positive charge starts to accumulate on the plate connected to the positive terminal and the same amount of negative charge on the other plate. This accumulation of charges creates an electric field between the plates. As charges on the plate increase, the electric field increases. In turn, the potential difference between the plates increases. After some short time, this potential difference between the plates becomes equal to the applied potential difference, V, and accumulation of charges on the capacitor plates comes to halt. Let plus Q and minus Q be the charges accumulated on the plates for the potential difference V. Let the area of each plate be A. Charge density on the positive plate plus sigma is plus Q by A. And that on the negative plate minus sigma is minus Q by A. From our earlier topics on Gauss's law, there is a uniform field between the plates, which is equal to sigma by epsilon naught. So, the electric field E is equal to Q by epsilon naught A. If the distance between the plates is D, the potential difference between the plates V is equal to E into D. Substitute E equals to Q by epsilon naught A. Q by V equals to epsilon naught A by D. Q by V is nothing but the capacitance of the parallel plate capacitor. Hence, the capacitance of the parallel plate capacitor is epsilon naught A by D. Summary: capacitance of a parallel plate capacitor with width D and area A is given by the expression C equals to epsilon naught A by D.